Hey everyone, and welcome. Today we're jumping into something that's at the very heart of programming, Python variables. Seriously, if you're just getting started with code, this is one of those core building blocks you've just got to get. So let's get right into it. So have you ever stopped to wonder, how does a program actually remember anything? Like when you log into a website and it remembers your username, or when you finish a game and it saves your high score? How does it hang on to that information? Well, the answer is a variable. And for now, the absolute easiest way to picture a variable is to think of it like a labeled box. Simple, right? You give the box a name, you put some information inside, and from then on, the program can find that info just by looking for the name on the box. That's really the big idea. Okay, so that's the theory. But how do we actually make one of these things in Python? Let's get our hands dirty and make this real, because you're going to be surprised at just how straightforward it is. It's literally a three-step dance. First, you pick a name. Step 2, you use the equal sign, which in the programming world we call the assignment operator. And third, you give it the value you want it to hold. And that's it. No fancy setup, no complex commands. Name equals value. Done. So let's look at an example right here. We've got user age, that's our name, then the equal sign. And what are we assigning? The number 30. From this moment on, Python knows that whenever we mention user_age, what we're really talking about is the number 30. And this is where the real power kicks in. See, once it's created, you don't have to type 30 over and over again. You just use its nickname, user_age. So if you tell Python to print user_age, it looks up that name, sees that it's pointing to 30, and boom, it shows you 30. The variable is a perfect stand-in. Now hold on. You can't just name a variable anything you want. There are a few simple rules of the road. And you know what? Knowing them is going to save you a ton of headaches later. So let's make sure you get it right every single time. Check out the pattern here. Over on the left, we've got the good stuff. User age, _count. They're all letters and underscores. But look at the right side. These are the classic mistakes. First place. Nope, can't start with a number. Dollar amount. Nope, can't use special characters like the $sign. And Zara salary? That hyphen is a no-go because Python thinks you're trying to do subtraction. So to wrap it all up, always start with a letter or an underscore. For the rest of the name, just stick to letters, numbers, and underscores. And this one's super important. Python is case sensitive. So age with a lowercase a is a totally different variable from age with a capital A. And finally, you can't use words that Python has already reserved for itself, like if or for. And hey, here's a little pro tip for you. The standard way to do things in the Python world is something called snake case. It's simple, all lowercase, with words separated by an underscore. It just makes your code so much easier for you and for other people to read. It's a total game changer for readability. Okay, so we know how to make them and name them, but why do we even care? Why are variables the absolute backbone of pretty much every program ever written? Let's take a look at how they come together to do some really powerful stuff. One of the coolest, most flexible things about Python is that its variables aren't stuck being one thing. For example, right here, we're creating a variable called age, and we're making it equal to a number, 25. Pretty standard stuff. But watch this. On the very next line of code, we can take that exact same name, age, and assign it a completely different kind of value. This time, a string of text. Age now represents 25. This amazing ability to change a variable's type on the fly, that's called dynamic typing, and it's a huge part of what makes Python, well, Python. So where do we see this in the real world? Everywhere. In calculations, variables make formulas make sense. When you ask a user for their name, you store it in a variable, and they're absolutely essential for controlling loops where a variable like I keeps track of how many times you've gone around. They are truly the workhorses of coding. All right, everything we've covered up to this point is the standard way most people think about variables. But now, we're going to peel back a layer and get to the real aha moment, what's actually going on inside Python. And spoiler alert, it's a little different from a lot of other languages. This quote right here really nails it. You remember our box analogy from the beginning? It's a great way to start, but it's not the whole story. In Python, a variable isn't the box itself. It's more like a sticky note or a label that you attach to the box. It's a reference, a pointer, that just points to where the real data is. And this is the key difference. In a language like C++, you can think of the variable as actually being the box in memory.
But in Python, the variable is just a name, a label that points to the value, which lives somewhere else. It's a small change in thinking, but it has huge implications.
This becomes crystal clear when you do something like this. A equals B equals 10. In many other languages, this would create two separate boxes, each with the number 10 inside, but not in Python. In Python, we create only one object for the number 10, and we just stick two different labels, A and B, onto that single object.
And here is where it all clicks into place. What happens if we then say A equals 50? We don't change the original object at all. We just create a new object, 50, and we move the A label so it points to the new guy. And what about the B label? It's completely untouched. It didn't even notice. It's still sitting there, happily pointing at the original number 10.
So let's wrap this all up. What are the big things to remember? Variables are made with a simple equal sign. For names, the Python community standard is sneak case. It just makes life easier. Python is dynamically typed, which gives you a ton of flexibility. And the biggest aha moment of all, Python variables aren't the boxes themselves, they're just labels that point to the data.
And that brings us to a final thought to chew on. If variables are just these lightweight little labels pointing to the actual data, what does that mean for how Python manages its memory? And how does that affect performance when all you're doing is moving labels around instead of copying huge pieces of data? That's the door this new understanding opens up. Thanks so much for joining me.